Okie dokie, let's do some data analysis. So, you are a totally awesome person working for an airline. You spend one day gathering data on flight delay times. For each flight that day, you write down how long it was delayed. If the flight wasn't delayed at all, you would write down 0 minutes. And at the end of the day, this is the information you got. You found that the mode is 0 minutes. So most flights weren't delayed at all. Cool. You found the median was 6 minutes. So that means if you took all of the data you found and you put it from smallest to biggest and you found the number right in the middle, it was 6. The mean was 10 minutes. So if you added up all your numbers and then divided them by how many you had, you'd get 10. And you found the maximum, the biggest number was 25. So, if you hear a cat, that's Murray. He's not interested in math, but he is interested in the birds out the window. So anyway, so with this information, your boss asks you these questions. And the first question is, what is the minimum delay time? Now, that's not one of the numbers you specifically wrote down when you were gathering information, but we can still figure it out. Because if you look at the number you have, what's the smallest one you see? The smallest one I see is 0. And it's true, there are numbers less than 0. You can have like -12, especially in Maine, -12 degrees. That's a thing. But we're talking about time here. And it wouldn't make sense to have negative time. So in this particular word problem, negative wouldn't make sense. So even though we didn't specifically say what the minimum was, our lowest number is 0, and it wouldn't make sense to go lower than that here. So I feel comfortable saying that the minimum would have to be 0 minutes. Can't have you wouldn't say my flight was delayed -12 minutes. That's just dumb. Technically, you probably wouldn't say it was delayed 0 minutes either, but the point is the minimum would have to be 0 minutes. Meaning no delays, which is good. That means most of the flights weren't delayed at all, so that's good. So then your boss asks you, what does this distribution look like? Is it symmetrical or is it skewed? And you're like, why do you care? But you're gonna do it anyway. So let me just draw out here. So this is a normal distribution, a standard one, more or less. And we get this particular shape if the mean, the median, and the mode are all the same number. Now our mean, median, mode are all different numbers, so we know for sure it's not going to be this shape. It's not going to be symmetrical. So let's see if we can figure out what it is going to be. And to do that, I'm basically just going to make a number line for myself to start. And my boss did tell me actually, no, my boss didn't tell me to label the axis, but they should have. I'm gonna. I'm gonna label this axis here as flight delay times in minutes. Flight delay times. And it's basically just going to be a number line for me. And I'm going to plot the numbers that I gathered from my day of research. Now, I found that the mode was 0. 0 would have to be over here. And I know that my maximum was 25. So let's put that over here. I've also got 10 and 6 to plot. So 10. Yeah, right there. That's about right. And 6 would be right about there. Okay. So we've got our numbers plotted out. Now let's see what the shape would be. Remember, this is what normal looks like. It's a normal curve. We also have left skewed ones that look kind of like this, and we have right skewed ones that look kind of like this. Let's see which one. This looks like eyes. I'm gonna draw. Let's see which one ours is. And so to do that, start with the mode. The mode is the tallest part of the distribution. If this were a bar graph, it would be the tallest bar. So let's say that our mode starts up here, tallest bar, if it were a bar. The median is the next tallest. So the median for us is 6, would be the next tallest. So it'd be right about here, can't be as tall. The mean would be the next tallest, right there. And then our maximum, we weren't told how often, how much the maximum was, but we know it's after the 0, the 6, the 10. So it's going to be the shortest one. So I've got these 3 little lines here. I'm going to connect them with as smooth of a curve as I possibly can. Kind of like that. Like that. I'm not going to touch this axis here. It's not going to touch. And this is what my distribution would look like. The mode 0 is the tallest part. Median would be the next tallest. And then 10 would be next, and then 25 would be the shortest. And you can see how this kind of looks like it's like the butt of a dragon here, where its tail is over here on the right. So we would call this right skewed. It's not symmetrical because the mean mode are not all the same. It is right skewed because it is kind of getting pulled towards the maximum of 25. This we would probably consider this fellow an outlier here because it's much larger. That's not gonna fit. It's much larger than the other numbers we were given. And so distributions get pulled towards outliers, whether they're big numbers or small numbers, and ours happen to be big. So, in answer to my boss's question, what does the distribution look like? Here it is. And is it symmetrical or skewed? It is right skewed. So my boss asked me, what percentage of flights were delayed less than 6 minutes? Well, I have this handy dandy distribution here. Here's the 6. Right there. Oh, that's almost straight. There's the 6. He wants to know how much is over here. Well, we know that 6 represents the median, and median represents middle. And if you cut something down the middle, like say a regular old box, if you cut it down the middle, you'd have half on one side, half on the other, right? It may not look like it visually with this distribution, but that's still how it works. When you cut this down the middle, you're going to have half on one side and half on the other. So to answer my boss's question, I would have to say that 50% was delayed less than 6 minutes. I don't even have to do any math. Just the fact that that is the median tells me there must be half less than that, which leads to the next question. How many were delayed more than 6 minutes? Well, there's the other half, the other 50%. So there's that. So then the boss wants to know, okay, so what are the pros and cons for using either the mean or the median when advertising our airline's delays time to the public? And I'm going to tell him, well, personally, I wouldn't use any of those. I'd use the mode because that sounds the best. I'd rather advertise most of our flights aren't delayed at all, 0 minutes, but he didn't ask that. So let's look at some pros for the mean first. There's going to be several. One thing that's good about the mean is that most people know what it is. Whenever we use the word average, we're usually talking about the mean. So that's a pro. It's easily understood. Easily understood. That's one of them. Pro for the mean. Easily understood. Not bad. Let's see. In comparison to the other numbers here, our mean was 10. It's not the best here. I wouldn't want to pick an airline based on the fact that they have an average flight delay of 10 minutes. I don't think I'd like that very much. But it is better than the maximum of 25, so you could technically consider that a pro if you wanted to. Better than the maximum. Yeah. There are a few cons for the mean though. Oops, not the mean. The mean. One of the cons is you see how on our distribution here, the 10 is closest to the 25. The mean always gets pulled towards the outliers. The mean gets pulled towards outliers. This is what causes a skewed distribution. And so that could be a con for us because our mean is closer to the 25. That might not be the best representation of what the average flight delay really is because of that 25. So that's a con here. The mean might not be the best representation. Is that how you spell it? Yeah. Of what the average flight, nope, flight, good Lord, delay. Oh my word. Sorry. Stop it. I can't type. Okay, so that's definitely a con. It might not be the best representation of what the average flight delay time is. And that's because it gets pulled towards outliers. The mean, as you know, is when you take all the numbers, add them up, and divide by what you have. So the mean is affected by every single number, which for good or bad. So there are more pros and cons. If you think of them, go ahead and write them down. You are the person working at the airline after all, but here are some pros and cons. It's easily understood. That's a pro. It certainly would sound better than the maximum. Con, it is affected by all numbers, especially the bigger ones. And it might not be the best representation. So there are some pros and cons for the means. But let's say we want the pros and cons for the median. just do pros first. Pros for the median. Remember, the median was the 6 minutes. One of the pros in this specific situation is that it's less than 10 minutes. You were deciding whether to use the mean or the median, and you got to choose between 6 or 10. In this case, lower numbers being better. I would say it, it's less than the mean, which would sound better. Sound more appealing to potential flyers for our airline. Yeah. A general pro for the median is it is not affected by outliers. The mean is, but the median is not. So you see how the 10 in our little shape distribution here, the dragon tail, is getting, it's closer, it's getting pulled towards the 25. The 6 isn't. The 6 is smack dab in the middle. Again, visually it may not look like it, but trust me, mathematically it is. So that's one of the general pros for the median. It's not affected by outliers. The middle is the middle, period. So that's definitely a pro. Let's look at a couple of cons. Let's see, what are some cons? One con I think of is not everyone knows what the median means. Most people don't know it until they take a math class, or maybe they learned it in third grade and then had to be reminded of it. So if I announce our median delay time is 6 minutes, some people might be like, what? I don't know what that is. So that could be considered a con in this specific situation. Very familiar with. You may think differently. I don't know. Let's see, some other cons. Now, for our situation, the median looks better of the two. Between 6 and 10 minutes, I'd rather wait 6 minutes than 10 minutes. But even though one of the pros for the median is that it's not affected by outliers, that's kind of like a double-edged sword. It could also be considered a con. The median does not take every value into account. So it also might not be the most accurate representation. Does not take every data value into account. Not representation overall. So it can be a good thing, that I think in this particular situation, the fact that the median doesn't take every data value into account works in our favor. But as a general con for the median, sometimes it's not always the best. Sometimes it is. I believe in the textbook they give like a general guideline. If you have numbers that are really far apart, really out there, really high, really low, then the median is usually best for that. In our case, our numbers go from 0 to 25. They may not seem really high, really low, but for the case of minutes, I would say that the median is a little bit better because it's not affected by that funky 25 outlier, that one flight that was late a long time. So you might be able to think of others. By all means, go for it. You can do a little bit of research online about pros and cons for mean and median and see how they apply to this problem. But here are just some ones to start you off. And I think with that, we've answered all the boss's questions. We know the minimum is 0 minutes, no delay. Distribution, we've got the right skewed one. We know that it was 50-50 as far as how many were delayed less than 6 minutes and how many were more. And we've got a few pros and cons for doing this. Personally, I'll be real with you. I would tell my boss, please, oops, why is it different text? Why different font? If I were writing a report to my boss, I'd say, please use the mode because it's 0 minutes and sounds the best. But that wasn't an option. I put it in there anyway because I can't let things go. But anyways, that should do it for our assignment for today. We have gathered some data, we analyzed the data, we found out what it looked like visually. We were able to use that to interpret a few different questions, and we considered some pros and cons for the different ways we can measure averages. Like I said, feel free to look up, do some research on mean and median for other pros and cons that you think might affect this situation, or if you have any in mind already, go for it. There is more than just the ones I have here. Other than that, I think we finished our question.